I'm going to talk about R and databases and interfaces today. But before we start, a very short survey. Who has worked with R before? Well, I have, sir. Who has used a data frame or a tibble in R? You can raise both hands if you use both. It's cool. So that's the basic data structure in R. But I need to sync up the slides. So that's not very helpful. Give me a second. Who has worked with a database before? Oh, great. Who has written a SQL query or an SQL query? Or I don't know what they're called. Oh, great. Okay, so I can skip most of my presentation. Thanks. Connected to a database from R. Wow, I'm amazed. Who has used DBI to do this? Okay, great. Who has defined a database schema? If you don't know what it is, probably you haven't, but great. Who has implemented a DBI backend? I'd like to talk to you after that. Good. Okay, so today will be about connecting relational databases to R using DBI, the package. Well, I'd like to make the presentation useful for you. You seem to have done this a lot, so even if you wouldn't have had this, I'd try to make it basic and include maybe interesting details for those of you who do this day by day. So, relational database is a storage of tables consisting of rows and columns. Each cell in the table would contain usually a scalar thing like a number or a string, pretty much like a data frame in R. So relational means that some tables and sometimes two tables can have the same set of columns with the same meaning, and rows in these two tables which contain the same values in these columns, in these common columns, would be related in one way or another. So big advantage of database is they store the data on disk. They're not limited to the RAM of the computer, unlike R, which means they can process large data sets, and they are specialized for retrieving portions of data and doing transformations on it. So I'm going to totally miss out on non-relational databases like MongoDB, Elasticsearch. This is NoDBI. The package by Scott Chamberlain would be the thing to look into. And I'm also not going into other ways of connecting, like the RODBC package, which I've seen is used occasionally. So that's the context here to connect to, let's say, a Postgres database. The DBI way to do this would be to load, to attach the database backend, our Postgres in this case, call dbconnect, which establishes the connection. In this case, the server runs on my local machine. I don't need to do to specify any host name or username or anything, but that's where this usually would go to. And then you can start submitting queries. In this case, a very simple hello world query. The string here is SQL, telling the database to return a table consisting of one row and one column with the content hello world. So that's how you do this for MariaDB or MySQL. Have you seen the difference? Yes. Just load a different package, use it for connecting, and use the same code for accessing the database. SQLite, a database that operates on files on your local machine. Still the same thing. This is not a coincidence. One other way to do this would be to not attach the database package, but to attach DBI instead. DBI is the base interface package. And then you tell DB Connect what database you connect to. So it can be a SQLite, like in the last example, Maria Postgres. There is a package to connect to ODBC, the Open Database Connectivity Library. Still the same code. So means, let me show you the whole setup. We have DBI at the base. We have packages, these database backends, importing DBI, implementing functions or methods defined by DBI. And on top of it, we have many more useful packages, solving things like data querying, updating data, defining database schema, etc. I'm going to show them briefly closer to the end. And your user code. So all of these usually talk via DBI to the database. You don't need to be specific about the particular database, except when connecting, and perhaps also when defining a query, because the SQL understood by databases is different from one database to another. So most of the time you don't need to specialize, but you still can specialize for individual databases. If you're writing code that is supposed to run on different databases. And even if you're not, still you have the advantage, you only learn one interface, the DBI, you just learn one set of functions, one set of methods, and you can apply it to connect to Oracle, to connect to SQL Server, and whatnot. Now, this isn't exactly a new thing. It's been around for quite some time. Not quite as old as R, but almost. But when I took on the project, it was only like halfway through there. We had the DBS syntax, so this means the function names and maybe the signature, so the argument names were in place, but there wasn't a definition available what each of these functions is supposed to do for different databases. And so the differences were not dramatic, but still, I think they were big enough to care. So we had differences for the data types that were returned for the same query for different databases. We didn't have good support for 64-bit integers, which isn't available in R, but which is very common in databases. So there were issues with character encoding, with time zones, corner case behavior, like what's supposed to happen if a table doesn't exist or if a query has a syntax error? What's supposed to happen if 0 rows are returned? So, and for some of the functions, there were optional syntax supported by just one backend, but not the other. So what I did, I wrote down this incredibly useful document. You can see the scroll bar. It's going all the way down. You can read it if you like. Maybe not. It's not that much of an interesting read, but still you can. It's useful reference if you want to understand how one or another function is supposed to behave. I tried to be comprehensive, and this thing is only half of it. So this is the text, and there's also code that implements this tests for these promises line by line. So this code can be run against the database backend and verify if it's compliant to the specification. So this is what we have for users. Interchangeable backends means you write code once that you use for different databases. If it's the same code, that's cool. Even if it's different code, you still just learn one interface to access. We have more reliable behavior, a better understanding what to expect from each of the functions, and, well, better documentation, I'd argue. And also implementers, those who deal with database backends. They get a test suite for free. You can start with a boilerplate which is available and just fill in the dots. And the expectations, what each method has to do are very clear. So today I'd like to walk you through DBI very briefly, show how you use it to access a database, show maybe some more recent developments as part of it, and then look into add-on packages that are useful when you work with DBI. So, what do you do with DBI? You connect, disconnect, we've seen this. You can look at what's available in your database. You can read or write entire tables. If you just want to import the data into R and work exclusively in R with it, if it's not too big. You can run queries that either return some result or perform an update on the database. Quoting is important if you program with queries. And transactions are just a basic feature of databases. I'm not showing this, but it's supported too. So for connecting, that's usually the first thing you have to do when you start working with a database. It can be tedious. So I tend to say once your connection to the database is good, half of the work is done, everything else just happens along the way. But you do it only once. So and this is, well, in an ideal world, this would be the only thing that differs across database backends. So different databases have different requirements of specifying how to connect to the database. For SQLite, which is a local database, you just have the path and maybe some options. For MariaDB, there is the notion of a configuration file, which would contain username and password and host name, so that you don't have to carry around credentials in plain text. Postgres may have other options. So these are documented, but not in DBI, only in the individual backends. Now, when you access the documentation for DB Connect, it has a nice feature. So when you open it, it shows just the generic documentation. But as soon as you load one or more database backends, it gets updated. You get links to the individual backends that implement this function, and you can look up detailed connection information for this. I think so. If only for this feature is useful and it works across all the methods in DBI. If the database backends provide additional information. So for discovering, for looking up what's in the database, we have DB list tables. This has been around all the time, I think. It returns a character vector of the table names, of the names of the tables that are available in a database. But this doesn't help you with schemas. So schema is very similar to a directory in a file system. It's a namespace where tables in a database are stored, but you need to tell the database where to look. And to list tables from a schema, we have the new DB list objects function. So this returns a 2-column data frame. The one column is the ID. So for the first 9 rows, we see the same results like with DB list tables. They are top-level tables. Is prefix false means there's nothing more. So the remaining rows are actually schemas. So if I have imported the NYC Flights 13 data, into my database. And I can look up all the tables in this schema with this syntax. So using the same dblist objects method, but now passing a schema argument, and it will list me the tables that are in there. And these ID objects are real things. You can use them to read, write tables, create them, remove them. I'll show this later. Now, the table argument is a misnomer, so I found an issue. And by all means, if anything's inconsistent or unclear, I really appreciate your help, because this project is kind of, well, we have an important milestone, but it's still, there's still some work to do, I think. So, for reading tables, we have read table, not surprising. It gets the table name as an argument, returns a data frame. I've used as tibble just to format it in a nicer way. And this also works with tables and schemas. So this ID object we've seen before, you pass it to read table, and read table knows how to interpret this. Now, this is for loading entire tables into R. Good for you if you have enough memory to hold your database. But sometimes you want to just limit the result one way or another. For this, you would write a SQL query. In this case, I've filtered the flights data to use only flights from January. The result set is smaller. So, as long as you work with constant SQL queries, that's okay. But if you want to think about returning flights from February, from March, and so forth, or have other ways, or you need other ways to modify your query, then you probably want to quote parts of it. Now let's look at this example. Month comes from a variable now. What do? We use paste. We use paste, and the query looks very much the same as before, except I don't think that's the scientific way to do this, right? We want to use db quote literal, and maybe for numbers we don't care, but there also could be differences. It's important for strings or datetime values, for example. There it makes a difference. But even for numbers, we have this very weird double colon notion. That's how we communicate to the database server. We want one of a particular data type. That's what db quote literal gives us. It's pretty new. If we want to parameterize on the column we use for filtering, we can do that. Again with paste, same results, but you probably want to use quote identifier in this situation to hedge against things like spaces, other weird characters, quotes in your variable name to protect against user input. So this is important to think about when your queries can be input from other users. Same with table names. Quoting also works for ID objects. Will give us this fully specified schema table name notation. Have I lost you yet? No? One more. You probably don't want to quote literals either. You want to use parameters in your query. Why? Well, it's easier, I think. It's easier to have a constant query. If month and table name were constant here, you could use the same query with a $1 placeholder, which is then substituted with actual values when you run db get query using this optional parameter params that would pass the actual values to fill into these placeholders when this query is run. So the advantage is the database has a slightly easier time to handle these because it only needs to parse the query once. And it's easier to write, a bit safer. Anyway, my head is spinning. This is a lot of SQL to think about, a lot of pasting. I'd like to show a simpler way of doing this, maybe. So if you have worked with a tidyverse, you're probably familiar with dplyr. Now there's also dbplyr, which implements the dplyr way of doing things for databases. The first thing to do is to create a table object based on a database connection and an identifier for the table. This returns something that looks like a tibble on your terminal, but it's not. You see in this first 2 lines of the output, it's just a handle. It still contains the database connection parameters and the table name, but it prints like a table. So, and you can do exciting things with it. You could filter and select and arrange and mutate and whatnot. Here, as an example, I don't need all the columns, and I want all the flights of February. Here I get them. So it's not fetching the data until I tell it to. This is just a preview. It's even more useful if you do summaries on your data. So imagine your data containing billions of rows. You can do the summary on the database. It saves you a lot of communication costs and a lot of memory on your system, if you can do this. Now I just said I want the mean. It's warning me that it cannot translate perfectly. I need to say an ARM true, but still it does the right thing. So the translation isn't perfect, but most idioms can be translated, and it's verbose if it's not. So if I give this an ARM true argument in the third line of the query, I'm getting the desired result without a warning. And what happens inside is that the operation just creates a proxy object that knows how to get the information from the database. So I'm using the SQL render function to get a view of the query. And this is pretty much the SQL I would have wrote myself. In other cases, it's going to create subqueries and making things complex. The database doesn't care. But what you see as a user is the group by summarize. In the grammar, you're perhaps familiar with when you're working with tidyverse on data frames as well. And when you need to bring in the data into your local memory, there's collect, and then it becomes a proper data frame. So that's just a brief walkthrough. I haven't worked that much on dbplyr, but I still think this is a bit underused, so give it a try if you haven't. So other interesting packages to look at. Our query is an alternative grammar, not based on the dplyr grammar of data manipulation, but more like relational algebra. DBX does update operations I have not implemented in DBI. Things like inserting, deleting. Upsert has been asked for very frequently, so this is you update only part of a table with new data that's linked with keys in an input data frame you give to the system. SQLR is a work in progress. This is for defining database schemas in R. So the idea is you write R code that describes how your database looks like, and then you can run it on your database to install the schemas, tables, indexes, relations, constraints, and anything else you need to make your database operational. So SF has gained support for spatial databases with the Postgres package, also based on DBI. And there are quite a few more DBI backends emerging. Big R query is for connecting to Google BigQuery. There's MoneyDB. ODBC is for connecting through DBI to a database if you have an ODBC driver installed on your system. And I'm sure there's a lot of more. So if I've missed anything, please just let me know. So take-home message maybe. We have a interface that tries to be consistent so that you can work with database in R and produce reliable, robust code for it. Now, before I finish, maybe an opinion poll. I've been thinking about a new syntax for this DBI because I always keep forgetting passing the con argument to the methods. What would it be if the code would be like this? Is this readable? Is this better? Is this much worse? Just let's discuss. I haven't filed an issue for that one yet. Anyway, that's it from my end. Thanks to our consortium, thanks to all the contributors to DBI and to all the backends and to all the packages on top of it. These are the links to my slides. The project has a web page. I'm Kirill, so thanks for being with me.